For this Lewis structure, we're going to draw a structure that violates the octet rule. Let's see how we can easily identify that this molecule is going to break the octet rule. Well, first we're going to start off in the same way we always do. Make a list of our atoms. 1 phosphorus, 1, 2, 3, 4, 5 chlorines. Have once. Looking at the periodic table, we see phosphorus has 5, once 8. Chlorines have 7 and 1 8. And we'll go ahead and fill out our chart here. And when everything's said and done, we have 40 electrons to do the work of, let's see, we've got 1, 2, 3, 4, 5, 6, 48 electrons. So 48 minus 40 equals 8 electrons, or 4 bonds. And it's at this point a red flag should go up, because we've just determined we need 4 bonds to hold together 6 atoms. It's not possible. So in this situation, what we're going to do is we're just going to go kind of brute force our way through it. We're going to start by putting the central atom, which is phosphorus. Whoops. And we're just going to connect all the chlorines to it. Alright. And then we're going to go ahead and put on our lone pairs. And we're going to make sure we keep track to not go over 40 electrons. That's how many electrons we had total to assemble. And getting in on our last one, that should be our 40th electron. So we've drawn a structure, now we have to go and look at its formal charge. Formal charge on chlorine, 7 valence minus 1 bond plus 6 electrons. Each chlorine has a formal charge of 0. The phosphorus here normally has 5. Is surrounded by 5 atoms, each with 1 bond. It has no lone pairs on it. Also has a formal charge of 0. So we've already done it. We've already drawn our Lewis structure that violates the octet rule simply by connecting each atom to the central one and then placing our remaining electrons on it. So that's an example of a molecule that violates the octet rule.